Hello my dear students, once again welcome back to our channel. So continuing our problem solving series and sequences and series, here I came up with the 99th question written on the screen. The fourth power of common difference of an arithmetic progression with integer entries is added to the product of any four consecutive terms of it. Prove that the resulting sum is a square of an integer they are asking. So let us suppose the four consecutive terms of that arithmetic progression be a minus 3d, a minus d, a plus d and a plus 3d, and all of them will be belonging to what? Capital Z or capital I over here, because they told the fourth power of common difference of an arithmetic progression with integer entries. That means these are all integers. All the terms are integers. Now what is the common difference of this arithmetic progression? 2d over here, then again 2d over here, then again 2d over here. So the fourth power of 2d is added to the product of this four consecutive terms. So that will be generating a minus 3d multiplied by a minus d multiplied by a plus d multiplied by a plus 3d. We have to prove that it will be the square of an integer. So this two will be generating a square minus 9d square minus 9d square. This will be generating a square minus d square, and that will be generating 16d to the power 4. So 16d to the power 4 plus a to the power 4 minus a square d square minus 9a square d square plus 9d to the power 4. Proceeding further, we are going to write like a to the power 4 minus 10a square d square plus 25 d to the power 4. That will be generating a square the whole square minus 2 times of a square multiplied by 5d square plus 5d square the whole square it will be. That means a square minus 2ab plus b square type of format is written over here. That means a square minus 5d square the whole square it would be. As we are already knowing that a plus d, a minus d, a plus 3d, a minus 3d are all integers, and due to the closure property of integer we do know that if a belongs to integer and d belongs to integer, then only all these numbers will be integer. And if a and d belongs to integer, a square would be belonging to integer, even d square would be belonging to integer. That means what? A square belongs to integer and 5d square also belongs to integer, and a square belongs to integer and minus 5d square also belongs to integer. That means what? A square minus 5d square also belongs to integer. That means what? The product of the four consecutive terms plus fourth power of the common difference will be generating a square of an integer, because a square minus 5d square belongs to integer. That was only to be proven by us. A square minus 5d square belongs to integer capital I or capital Z. That means the product of four consecutive terms plus fourth power of common difference will generate the power of an integer, the square of an integer. Sum is a square of an integer. Hence we have proven this thing. Hope you guys would have understood it, would have enjoyed it. Thanks for watching my dear students.